This lecture explains the format of OpenGL functions and programs. Let's look at the format of OpenGL functions with a couple of examples. Here we have a function that defines a uniform variable for the current program object. Uniform variables are used to communicate with your vertex or fragment shader from outside. We will study this in detail later. The function name is GL uniform3f. GL basically means that this function belongs to the core library. Uniform is the name of the function, which specifies what this function is doing. 3 means 3 dimensions, which is the x, y, and z dimensions. And f means that these dimensions are of type floats. Now, another variant of the same function is GL uniform3fv, where the v means that this is a pointer to an array, and hence we only pass on one parameter, which is the pointer to the 3f array. OpenGL defines. Most constants are defined in the include files gl.h, glue.h, and glut.h. Note that include gl/glut.h will automatically include the other libraries. This is because glue.h builds on top of gl.h and glut.h builds on top of glue.h. The functions glenable and glclear are both declared in gl.h. We can tell this because these functions have the prefix gl rather than glut or glue. The OpenGL data types glfloat, gldouble are also declared in gl.h. Generally, definitions that are present in glue or glut will have a prefix glue or glut with them. Glsl is short for OpenGL shading language. Glsl is a high-level shading language which has a syntax similar to the C programming language. It has built-in matrix and vector types, 2, 3, and 4 dimensional. It has overloaded operators and C++-like constructors. It is similar to NVIDIA's CG and Microsoft's HLSL, high-level shading language. GLSL supports loops and if-else constructs, but recursion is not allowed. GLSL are not standalone applications but require an application program that uses the OpenGL API. GLSL has new OpenGL functions to compile, link, and get information to shaders. We will study GLSL in detail in later lectures. Let's look at a simple program that generates a white square on a black background. We will call it simple.cpp. Most OpenGL programs have a similar structure that consists of the following functions. The main function that creates the window calls the init function, which is the initialization function. It specifies a callback functions relevant to the application and enters an event loop, which is the last executable statement. The init function defines the vertices, attributes, etc. of the objects to be rendered. It specifies the shader programs about which we'll read later. And then finally is the display function. This is the callback function that defines what to draw whenever the window is refreshed. Let's look at a rather very simple version of the simple.cpp. This is not the full program, but just shows the structure. First we include glut.h, which also includes the core gl.h library. We define the initialization function, and then we define the display function. We clear the buffers over here and insert the rest of the code after this. We can call this any other name that we like. This display function will be called every time the window is refreshed or every time we want to refresh the window because we have made some changes to the objects or the lighting. This is the main function where we start with creating the window and calling it simple. Then we call the initialization function, which sets up the OpenGL state and initializes the shaders. Then we define our display callback function, telling the program that execute this function whenever a change has been made to the display window. And then finally we enter an infinite event loop. Note that the program specifies a display callback function named myDisplay. Every glut program must have a display callback. This is OpenGL. It is about displaying graphics, and hence we must have a display callback. The display callback is executed whenever OpenGL decides that the display must be refreshed. For example, when the window is opened or the window is dragged. The main function ends with the program entering an event loop, which is an infinite loop.